Let's move to the question number 2. The diagram shows the curve with equation y is equal to 2x square minus 5 over x plus 3. The curve crosses the x-axis at the point P. This is a point, this is a curve, and P is equal to 1, 0. So this one is 1, 0. And the M is the minimum point. This is the minimum, or you can say minima. Find the gradient of the curve at P. We need to find the gradient at P. To find the gradient, we need dy over dx. This is the gradient equation, you can see that. And to find the gradient at a specific point, we will plug that specific point in the derivative equation to get the gradient at P. So we need dy over dx. So we have y, which is equals to 2x squared minus 5. We can write x as a x inverse plus 3. So we need to derivate it. So dy over dx is equals to the 2, and x squared derivative is 2x minus 5. Derivative of x inverse is negative 1 times x to the power of negative 1 minus 1, and derivative of constant is 0. So we have dy over dx is equals to the 4x plus 5x to the power of negative 2. Further solving, we will have dy over dx is equals to 4x plus 5 over x square. This is the equation of derivative of the given curve. We need to find the gradient at P. So gradient at P is equals to the derivative at point P. So this one is equals to the x coordinate of P is 1. So we can say that x is equal to 1. So we will plug this value of x is equal to 1 in the derivative equation. We will have 4 times x means 4 times 1 plus 5 over x square means 1 square. So this one is equals to 4 plus 5, which is equals to 9. So we can say that gradient at P is 9. Part B. Find the coordinate of M. Give each coordinate correct to 3 significant figures. This is the minima, and we need to find the coordinate of minima, which is the stationary point. And we know that when we equate derivative of the curve with 0 and find the value of x, so this is the stationary point. It can be minima or maxima both. So we need to equate dy over dx with 0. So this was dy over dx, and equate it 0 to find the value of x coordinate of the stationary point. So 4x plus 5 over x square is equal to 0. For the solving, we will have x square and 4x cube plus 5 equal to 0. 4x cube plus 5 equal to 0. Further solving, we will have 4x cube is equal to negative 5, and x cube is equal to negative 5 over 4, and x cube is equal to negative 1.25. Cube root both sides. So x is equals to the negative 1.077, and we need to find the each coordinate up to 3 significant figures. So we can write this one as x is equal to 1.08 negative. This is the x coordinate of the stationary point, or you can say the minimum point. Now plugging this x coordinate of the stationary point in the equation of curve to find the y coordinate. So plug x is equal to negative 1.08 in curve equation, and we know that curve equation is y is equal to 2x square minus 5 over x plus 3. When we plug x is equal to negative 1.08, we will have 2 times negative 1.08 square minus 5 over negative 1.08 plus 3. So we will have y is equals to 2 times 1.1664 plus 4.629 plus 3. So y is equals to the 2.3328 plus 4.629 plus 3. So y coordinate is equals to 9.9618. And we need in the three significant figure, so y coordinate in three significant figure is 9.96. Three significant figure. So we have the y coordinate and x coordinate. So the point M, which is the minimum point, is equals to x coordinate, which is negative 1.08, and the y coordinate is 9.96 in three significant figure. Sometimes students overlook the significant figures.